Olivia, I've been trying to work out why I can't understand 2605. I've been attending all my tutorials and I've been reading all the slides put up on Moodle and I still don't get it.
Well, have you been attending your lectures?
Lectures?
Yeah.
What are lectures?
Well, if you attend your lectures, you'd have a better understanding of the course, and our lecturers Yenny and Michael could help you out the end. Here, let me show you an example.
If you only read the assigned lecture readings every week, you're bound to not understand the week's content. This pulls you further behind other students and increases the chances of you failing the course and having to retake it. On the other hand, if you attended all 12 lectures, you'd gain a better insight into the Java topic. This provides a greater chance at getting a HD in this course.
You're probably asking yourself, what is Java animation? There is no single predefined method for creating animations in Java. However, all of the methods I'm about to explain all have one thing in common, and that is, they have the ability to make images move. The various techniques used to create animation include the use of swing timers and threads. In order to get started with Java animation, you will need to use a graphical user interface toolkit or API such as Swing or JavaFX, which allows programmers to create widgets and import images into the user interface. You'll later see that we chose the Swing API due to the rich amount of information available regarding the practical use of Swing, and the base code used to build our animation existing in a Swing environment. On to the techniques used for Java animation. A thread is a program unit that defines a path of execution. For example, we need to take a simple journey from point A to point B. Easy enough, right? But what if, in order to get from point A to point B, we needed to do a few other things at the same time? A single thread would not be able to support this problem, as such because the program running on a single thread is unable to handle more than one event at a time, and the object will never be able to reach point B. This is where multi-threading comes in handy. Multi-threading involves handling multiple events concurrently. This is done by the Java virtual machine executing each thread for a short amount of time before switching to another thread, giving the illusion of executing the threads in parallel with each other. Now, how does this relate to Java animation, you may ask? Let's say you wanted to create a game where an object is continuously moving in a pattern that you have defined in your code. But what if you wanted to control that moving object's direction of movement with arrow keys? The program will not register the arrow key input, and the ball will continue moving in its predefined pattern because multi-threading is needed. Moving on to swing timers. The swing timer class can be used for multiple simple animations. Swing timer provides a unique wrapper which presents threads in an event-driven manner. The swing timer fires an action event at specific intervals, which is handled by the action listener. This concept will be explained in further detail and shown in a practical example shortly.
So you're probably wondering what's the logic behind this. Well, let me show you. Getting inspiration from the basic Snake game, I had two codes act as a guideline in making this demonstration. The public class window has two methods, the first being the main method and the second being create frame. Here we create a JFrame as a container for the draw panel instance. This is because there isn't any freedom to draw on a JFrame like there is on a JPanel. Certain properties have been set for the JFrame, the background color being set to white, resizing of screen being prohibited, and the program closing when the user closes the frame. We then invoke the createFrame method in the main method and hence create a window. The panel instance can be attributed to the second class of this package. To explain, drawPanel is a subclass of JPanel, and the class implements two event handlers, action listener and key listener. We have also defined a set of variables, but for time's sake, we'll comment the definition above like this. The constructor of the class adds a key listener method to handle any keyboard events, such as when a key is pressed, released, or typed. It invokes the corresponding method in the listener object, and the key event is passed to it. This represents the drawPanel class. setFocusable has also been declared true to allow the component to retrieve the focus, and we have instantiated the timer at this point to set the student's speed at 100 and start the game. The paint component method is automatically called by the UI thread and remains empty upon invocation. So we override this method to perform our own drawings, using the graphics object as its sole parameter. So firstly, for decorative purposes, we create a border for the title. We colour it in yellow and set the positioning and size of the border. Then we assign an image icon to the variable UNSW logo and paint it on the title border. After that, we identify the default position of the student. When moves is equal to 0, that is the student doesn't move, it will start at the X and Y intercepts 100 and 100. We then paint a student icon onto the same position, using the same method for the UNSW logo. Here it is made clear that the student X and Y index 0 is equivalent to the student head. To explain the next line in the code, once a student attends a class, their IQ level improves. Hence, the for loop and if statement is used to explain that a student's IQ level is represented by the number of array indexes. So if A is equal to 3, it clears the condition that A does not equal to 0, and is thus painted on the board as the student X and Y index 3. The following line explains that the student's head, that is, its student X and Y index 0, must match the lecturer's randomized X and Y positions to successfully attend the lectures. This improves their IQ level, which is incremented by the student IQ counter. The next lesson is then randomized again and the whole process is painted onto the board. This code explains that if the student's X and Y index I, where I represents the IQ level, hits the position of the student's head, all Boolean moves are set to false. This stops the student from moving, and the following code states that the student has failed the course and needs to enroll again. On the other hand, if the student were to reach all 12 lectures, they will receive a HD. The reason why student IQ is equal to 30 is because we assume the standard student IQ level would originally be 1 as initialized earlier. Looking at the event key handlers, we have two particular methods to examine, the first being key pressed. So this implements the movement of the student based on arrow keys. getKeyCode is a method which returns the event's virtual key code, which are used to report the keyboard key that has been pressed. So we've divided the keys into its 4 directions, and we'll focus only on left move as the rest follows a similar pattern. So if the variable key is equal to the constant vk_left, which represents a non-pumped left arrow key, and isn't a right move, then moves will be incremented and the student moves to the left. All other moves are set to false. Next, we take a look at action performed, where we shift the position of the student depending on which arrow key is pressed. We've again split this into the 4 respective arrow keys, but we'll only explain right move as the rest follows a similar pattern. For right move is true, that is, the user has pressed the right key, the student's position on the board is shifted to the right. This is demonstrated through the for loop, so if I is equal to 2, then that would mean the image icon stored in student Y index 3 would move to the student Y index 2. In simple terms, this means the position of the student's 3rd IQ level has moved to the position owned by the 2nd IQ level. Thus, the student is moving to the right. The second for loop statement goes even further by explaining that if student index is 0, the position of the head shifts to the right by 25. And to make this game less restrictive, the student is also able to move towards the right border and come out from the left border. So if the student's X position is larger than 850, it gets called back to its position at 25 and continues moving. The repaint method refreshes the view, so when these components are changed, it must be called. And that's it.
Oh, that makes so much more sense now.
Yeah, exactly. That's the way to go.
Gotta go to my lectures now.